What's up, everybody? Welcome back to yet another episode of Basic Chem 101 with Sihlebonani. My name is Sihlebonani, and today we continue with determining formulas. We'll be dealing with molecular formulas and empirical formula.
Let's go. This is for every child that wants to make it one day. Izimbo class and presence of mind is elsewhere. Cinga uzuzani afuna kuhle already alisibani and the timer is nowhere. I know your pain, you don't have to be scared. The dreams are very pure, they the written and focus. Keep that pen and paper, they will take you to that day. In the meantime, stand up, help me.
So, what is an empirical formula? It is a formula, of course, written in smallest or simplest whole number subscripts. That is your empirical formula. Meaning, if this is your C2H2, if this is your molecular formula, the simplest, these are your subscripts, the simplest whole number subscripts that you can write for C2H2 would be CH. So this is the empirical formula for C2H2. So a molecular formula basically will be a multiple of your empirical formula. If you multiply this by 2, you get C2H2, but you can also get C6H6. This one is your acetylene, and this one is your benzene. So you'll find out that your empirical formula for different molecules can be the same. If the empirical formula is the same for these two, it means the mass percentage of C2H2 is equal to a mass percentage of C6H6. So if you have your empirical formula and your mass percentage, it can be difficult for you to determine your actual formula of your compound. So one other thing that can lead us to determining the formula of an unknown compound would be for us to find the molecular mass, or to be given the molecular mass. This one can be given, and it can also be determined by big machines like your mass spectrometers. So you can find a compound and you can find its molecular mass using your mass spectrometer, and you can find that it contains certain compounds. For an example, you can find that it contains carbon and hydrogen. If you know how much of carbon is there, and if you know how much of hydrogen is there by mass percentages, you can be able to determine the empirical formula of that compound. But if you have your molecular mass from your mass spectrometer, for an example, you can be able to determine the formula of that compound. Let's make an example. Remember from our previous session, we determined the mass percentages from an unknown compound which contained carbon, hydrogen, and oxygen. And if you could get your mass percent from that example, you could be able to determine the mass of each element or atom in that compound. So from there, mass percentage can lead you directly to determining the empirical formula of your unknown compound. So in this example, we'll be using the mass that we calculated, and I didn't finish. I hope you did finish it, or you can go back and finish for yourself. But these would be the masses that you would get. Now, the main thing about empirical formulas, it is the mole ratio. It is actually the mole ratio of different elements in a compound. If we said this is C2H2, the mole ratio of hydrogen and carbon is, for one carbon there is one hydrogen, so the mole ratio is 1:1. So in this instance, we'll have to calculate moles first. Then from the moles we can relate the moles so that we can see what is the ratio between different elements in that compound. So this is in milligrams. Let's change it to grams, because your molar mass is usually in grams per mole. So this is, so the first step would be to calculate your number of moles, which is 12 grams per mole. And then you would get 0.0000141 mole. Then divide by 1.01 gram per mole. Then you would get 0.000282 mole. Then you divide by 16 gram per mole. Here you would get 0.000141 moles. Then what happens next, for you to be able to determine the mole ratio, you would have to divide by the smallest value of moles here. So if you can look here, you'd find that 0.000141 is the smallest. So you divide throughout by 0.000141. Then here you'd get 1. Here it's 0.000141 mole. Here you'd get 2. Then you'd get, if this is 0.000141, here you'd get 1. So if that is the case, the empirical formula is CH2O. But now for a molecular formula, you would have to multiply, because a molecular formula is a multiple of your empirical formula. You'll have to multiply by an unknown number, which you can get by, this number would be your molecular formula mass divided by empirical formula mass. Now, in this example that we are doing, they gave us that the molecular formula mass of this compound was 60. So if therefore it's atomic mass units divided by this one, if you can calculate, you'd find that it is 30 atomic mass units. And then your N would be equal to 2. So your molecular formula would be C2H4O2. That is how you'd calculate you determine your molecular formula from a given mass, or from being given a mass of your unknown compound, it calculates your mass percentages first from your combustion, as in our example. But if you have your mass already, you can determine the empirical formula, and then you will have to be given, or you have to know, the molecular formula mass of that compound, so that you can be able to multiply your empirical formula to have an idea of your molecular formula. And by the way, for this example, our compound was acetic acid, and acetic acid is CH3COOH. And if you look at this, it's the same as this one. You have 2 carbons, 4 hydrogens, and 2 oxygens. So if we followed everything correctly, we find our mass as that one. Sometimes it be given only the mass percentages. If you are given only the mass percentages and they say calculate or determine the molecular formula of your compound, you'd have to use that mass percentage to convert your mass percentages to mass. Sometimes you'd have to assume that your whole compound is 100 grams. If your whole compound is 100 grams, then the mass of those elements that you are given will be equal to the mass percentage that you are given. Once you have the mass, you can calculate the number of moles. Once you have the number of moles, what you can do is you divide by the smallest number of mole, and then it gives you the ratio of your moles. Once it gives you your ratio of your moles, you have your molecular formula mass. You multiply it to your empirical formula, you get your molecular formula. But what you'll have to note though is once you divide these things, these moles, the answer that you get must be an integer, or it must be a whole number. If it's 2.5, that you will not accept that. You'll have to multiply throughout by another whole number until you get to a place of you are getting a whole number. Maybe it's best if we do an example, right? Okay, let's do it. This is our last example. Let's say you are given benzoic acid and you don't know the molecular formula of benzoic acid, and you just know the atomic mass of your benzoic acid, and you also know the mass percentage of each atom in benzoic acid. Your benzoic acid is made up of carbon, hydrogen, and oxygen, and carbon is 68.8%, and hydrogen is 5%, and oxygen is 26.2%. Now you want to determine the molecular formula. So from here we can get your empirical formula, and from your empirical formula you can be able to get your molecular formula. Now, because we don't know the mass of benzoic acid, so we'll assume that in 100 grams of benzoic acid, carbon will be equal to 68.8 grams, hydrogen will be equal to 5.0 grams, and oxygen will be equal to 26.2 grams. So you first determine the number of moles, which is 12.0 gram per mole. Then 1.01 gram per mole. Then 16.0 gram per mole. Then you get 5.73 mole then you get 4.95 mole. Then you get 1.64 moles of oxygen. Once you get those moles, you divide throughout by the smallest number of moles, which is this one. Then here you'd get around about 3.5. Then here you'd get about 3.01. Then here you'd get 1. Now, because here you have 3.5, we can take this one because it's 3. If you round this off, you get a 3. Here, this is a 3.5. So you need a whole number. What you can do is you multiply by, you can start from 1. If you multiply by 1, it's not going to change anything. So we can multiply by 2 throughout. So we'll multiply by 2 throughout. Then here we'd get a 7. Then here we'd get 6. Then here we'd get 2. So this would be your empirical formula. Let's put it like this. So your empirical formula would be C7H6O2. Then if you calculate this, the empirical formula mass, would be equal to, it would be the same as what we are given there, which is 122.12 atomic mass units. So your N would be equal to 1. Now, for benzoic acid, the empirical formula will be the same as your molecular formula. Because if you look at this, this is the smallest or the simplest whole number subscripts that you can find here. You cannot divide by anything. So the empirical formula and the molecular formula for other compounds is the same, but for others, you have to determine that number N so that you can know if there is a need to multiply your empirical formula or there is no need, such as in this case. Now, that is how we come to the end of our lesson for today. If you got any value to anything that we have spoken about so far, please subscribe. If you have subscribed already, thank you very much. Please like, please share, and we'll see you on the next one. My name is Sihlebonan, and this has been Basic Chem 101 with Sihlebonan. I'm God.